We talk about constant rate of change. Recall, that's looking at the slope. Rate of change is the slope. And what we want that to be is constant. We want it to be always the same. So let's look at the slope of this particular situation when we're looking at money versus hours. And if I'm going to show the rise over the run from one point to the next, rise, run. See, I rose 5 according to my scale, and I ran 1. Let's see what happens in the next hour. Rise 1, rise 5, run 1, rise 5, run 1. So you can see that that's a constant rate of change. Now, if I were to connect these dots, I would have a linear equation. So when we have a constant rate of change or slope, we have this thing called a line, which we like to call a linear equation, a linear function, because it shows a line. Let's go ahead and check this table here below. In the table, let's see if we have a constant rate of change. Sometimes we just want to look at data instead of graph. Now, if this is real-world data, and it's the number of home computers per millions, what's homeowner computer ownership? Well, if I look, this would be my X. And I am going up by 1 year, so that's a constant rate. And on the millions of computers, I'm going up by 5 million. Oh, here I'm going up by 5 million. Here I'm only going up by 4, but here I'm going up by 5 again. We do kind of have this little difference, but if this was real-world data, it would be somewhat linear. It's fairly constant in its increase. So my slope, remember home computers is Y, is change in Y, which was 5, over change in X. So this too has a slope of 1. So we're looking for this constant rate of change. So if I was to graph it, I would be able to form a line. Lines have equations. And we're going to kind of look at the general equation of a line. And it is going to be of a particular form. The form looks like this. Y equals the rate of change. And we're going to put an X next to it because the rate is going to be either 1 rate or 2 rates or 3 rates. And then we're going to add to that our start value, our initial value in which we're going to start at. So if I wanted to write an equation of this form, in general it would look like Y equals of the equation up above here. I started with 37, and my rate of change in my slope was 5. So the equation for this would be 5x plus 37. In general, we like to say we have what we call a slope-intercept form. We call it this form because my slope is located in this position, the rate of change, and my what we call my y-intercept, or my start value, is located in the second position. So B is going to be called my y-intercept. So if you recall, it has an ordered pair 0b. It's where it hits my y-axis. My slope then is going to be the letter m. And it's always found in this position next to the x. That would be my slope. Slope then is going to be found by change in y over change in x, the rise over the run, or the formula y2 minus y1 over x2 minus x1. So let's just start with giving you equations, and let's see if we can't pick off my slope, which is m, and my y-intercept, which is b. So matching the form, notice the 3 and the m correlate. So my slope then has a value of 3, and oftentimes we're not looking at slope, or looking at slope as just a particular number. We like to see it as a fraction, so I can see the rise over the run. But 3 is fine. The y-intercept corresponds to -1, and yes, you do need the -1. In the next situation, it's not of that form y equals mx plus b. I need y to be by itself. So the first thing I'm going to do is I'm going to move that 3x to the other side of the equal sign so I can manipulate what we call standard form into the special form y equals mx plus b. In order to get rid of the 4, it's 4 times y. I'm going to divide. So looking at this, I have y equals negative 3/4 x plus 2. Now it's of the form y equals mx plus b. My m slope is negative 3/4, so we know that this is going to go in the downward direction, and my y-intercept is 2. The last situation is the same as the second. We again want to have y by itself, so I'm going to move the 2x over, and I have negative y equals negative 2x plus 3. We want y equals mx plus b, not negative y. So I'm going to divide by negative 1 because we can see a 1 there. If I divide everything by negative 1, y equals 2x. See, a positive divided by a negative is a negative. And now I'm of my form, y equals mx plus b. So I went from this thing called standard form into a special form called slope-intercept. My y-coordinate is got to be by itself. So these values correspond. M, if you recall, is my slope. So it's a positive line. It's going to be going uphill. And it's going to be a fairly steep rise 2, run 1. And my y-intercept is negative 3, meaning it's going to be located on the y-axis at negative 3.